All right, so welcome back. Today in this video, we're going to be looking at surveying. And as you're studying for your Civil FE exam review, definitely going to need to have mastered the surveying section because it does have quite a few topics. So the first topic that we're going to cover, when I say subtopic, meaning that, or not that one, this one. But it has 5 different topics. So we'll look at angles, distances, and trigonometry in this video. And in the following videos, we're going to look at area computations and so forth. So let's go ahead and do and start these practice problems. So number 1 says a man standing at a certain distance from a building. Observe the angle of elevation of its top to be 60 degrees. He walks 30 yards away from the building, and now the angle of elevation of the building top is 30 degrees. How high is the building? So they've drawn it out for us by what they mean. And so we want to go ahead and write out the information that we're given. So we're given all of the angles. All right, so we are given the angles / visuals of where the man is standing. So he's standing, right? He would be standing right here and right there. That's what it's describing. Okay. And so what are we trying to find? Well, we're trying to find the height of building. Okay. So the formula is needed. There are no like super fancy formulas that you're going to need. Don't believe. But I do believe that you need to have like an idea of what, sine, cosine, and all of those, what those mean. So you can remember SOHCAHTOA, right? Sine is always going to be opposite over hypotenuse. Cosine is always adjacent over hypotenuse, A over H. And then tangent is normally equal to opposite over adjacent. SOHCAHTOA. Okay. So let's continue. So those are I guess you could call the formulas that we need. So let's write it out in terms of how can we start trying to work at this. So I believe that if we start out by saying, okay, if I take angle 30 degrees, right? And I say the tangent of 30 degrees equals, well, opposite, right? H over adjacent, which is 30 yards plus D. Okay. Is there anything else that we can do with this? We can create another formula that states that if we look at the next point where he stands with the 60-degree angle, we could say that the tan of 60 is equal to H over D. Right? All right. So now we have two formulas that both share what we're given in terms of h and d, right? So now we can isolate one of the variables and plug it into the other formula and hope we get a value for either h or d. So I'm gonna solve for h in this case. So d tan 60 is equal to h, right? Just brought this down. Okay. So I have h. So what I'm gonna do is plug this formula in for h here, right? And so I should be able to get d, right? So what does that look like? Well, it looks like the tan 30 is equal to d tan 60 all over 30 plus d. So hopefully you can see that I substituted that h in blue. All right. So now what do we do from there? Well, I'm going to move everything to the other side. So I'm going to multiply by 30 plus d, and I'm going to get 30 tan 30 plus d tan 30 is equal to d tan 60. All right. I don't know if you all can see that. So there we go. Okay. And so when we keep solving for this, all right, I get d to equal to 14.99 or 15 yards. We're not solving for d, we're solving for height. So now that we have d, we can plug it in. We can plug it right back into our equation. And we can plug it in for d here. So then I will say that 15 tan of 60 is equal to h, right? And so h is equal to 25.98 yards or 26 yards, which is what it rounds up to. All right, so it's got to play with sine, cosine, and create some formulas, substitute your variables. All right, let's look at number 2. All right, this one says 2 survey points have coordinates 100, 200 meters, and 300, 400 meters. Calculate the horizontal distance between the 2 points. So basically, if you really want to look at this, all right, we'll say 100, 200, 300, and 400. And the survey points are, and we'll do the same thing for up top. 1, 2, 3, 4. This one's 100. This one's 400. Okay. So we got one of the points is at 100, 200. So here. Every time I, okay. And then we have another point. Mark it in red. It's 300, 400. That makes sense. So it's asking for the horizontal distance, which is from here to here, right? So what's that horizontal distance? Well, I'm not going to waste too much time, right? We're given some points. We're trying to find horizontal distance. Formulas you need, you got your X and Y coordinates. Just use your X values if you're trying to find horizontal. And to get that, I would keep things very simple. Take my, I would say the 0.2 minus 0.1, all in the X direction. So I'll say this is 0.2, this is 0.1, and I can have my X. And so I'd say 300 minus 100 is equal to 200, which equals B. Very straightforward, not super difficult. All right, let's look at number 3. Given a slope distance of 150 meters and a vertical angle of 10 degrees, calculate the horizontal distance. All right. So what are we given? Given the slope distance and a vertical angle. All right. If I draw this out really quickly. What is a slope distance, right? Slope is just rise over run. So if I know my slope distance, 150 meters, right? And it's at an angle, 30 degrees. So I drew it this way. Or not 30 degrees, I'm sorry. 10 degrees. And we're trying to find the horizontal distance. Horizontal distance. Then, to me, we need to find the X component of this. And how do you find the X component? Well, cosine is typically, this is going to be this is the X component that we need of it. And green is the X component. So typically, to be able to get that, you would need to do the cosine. So you could say the cosine of 10 degrees is equal to adjacent, which is X, over hypotenuse, which is 150, right? So X is what we're solving for, which is the horizontal distance. So X is equal to 150 times the cosine of 10 degrees, which when we put that in our calculator, you should get 147.7 meters or 148 meters. That's what it rounds up to be. Also, if you're getting a different answer, make sure your calculator is in degrees. It's not in radians. All right, so that concludes this section, we literally were in angles, distances, and trigonometry. Pretty simple, straightforward. Just got to know sine, cosine, tangent, be able to write them in terms of variables. So in the next video, we're going to look at area computations. So I'll see you in the next video.